27. Yes, Jasmine. 29. Okay, here we go. 21. Okay, you're given y is equal to 1 over 5x minus 3, and they want you to find y prime of 1. So let's go ahead and find y prime of x. Okay, this is a quotient, therefore I'm going to use a quotient rule. Quotient rule says denominator times derivative of the numerator minus the numerator times derivative of the denominator. All that over denominator squared. Okay, you will be tempted. Yes, sir. Daggone it. Can't take a derivative of 1. Alright. Okay, any questions? Alright, you will be tempted to simplify this and then plug in, and that's fine because you're also exposing yourself to algebraic errors. So it's much easier if you were to plug in and then simplify. Okay, so y prime of 1. Okay, when you plug in 1 there, it's going to be 5 minus 3, which is 2 times 0. Okay, minus 1 times 5. And then on the bottom, you're going to plug in 1. That's going to give you 2 squared, which is 4. Okay, and then top, you're going to get negative 5. Bottom, you're going to get 4. Okay, so that's it. Let's go to number 25. 25. Okay, they give you y is equal to 2x minus 1, all that over x plus 3. And when they tell you to find dy dx and evaluate that x is equal to 1, okay, this is the same thing as y prime of 1. That's what that means. Okay, so let's find the derivative. I'm going to use a quotient rule. Denominator times derivative of the numerator minus the numerator times derivative of the denominator, all that over denominator squared. What am I going to plug in? 1. That'll be 4 times 2 minus, this is going to be 1 times 1, all that over 4 squared, which is 16. Just clean it up and that's done. Okay, 27. You have y is equal to 3x plus 2, all that over x, and then times quantity, x minus 5 plus 1. Okay, they want me to find same thing, derivative, and evaluate that at 1. So I'm trying to find y prime of 1. Okay, so sometimes it's easier if you do some algebra up front, and I'm going to do that in this situation because I don't want to use a quotient rule. I can, but I don't want to use a quotient rule because it's just sometimes this gets ugly. This is 3x over x plus 2 over x times x to the negative 5 plus 1. So that simplifies to 3 plus 2 to the 2 times x to the negative 1 times x to the negative 5 plus 1. And then we can take a derivative of that using a product rule. First, which is 3 plus 2x to the negative 1 times derivative of the second, which is negative 5x to the negative 6, plus second, which is x to the negative 5 plus 1, times derivative of the first, which is negative 2x to the negative 2. Now I'm plugging in 1. When I plug in 1 here, that turns into 2. 2 times 2 plus 3 is 5. When I plug in 1 here, there's the negative 6 power. I'm still going to get 1, so it's going to be negative 5. And then plus, plugging in 1 here, 1 plus 1 is going to give me 2. Plugging in 1 here is going to give me negative 2. Okay, that's done. So 29. 29, okay, they give you the function f of x is equal to x to the third minus 3x plus 1. And they want you to first find f prime of 1, which is easy. F prime of x is 3x squared minus 3, and f prime of 1 is going to be 3 minus 3, which is 0. Okay, so we know the slope of this curve at 1 is 0. That means it's flat. Okay, but they want you to use the regular slope formula, which is f of x minus f of 1, all that over x minus 1, and then they want you to pick a number close to 1 that you can use for the x. So give me any number. 1, 2, not close to 1, not 1, 2. Okay, so if you plug in 2, you're going to get f of 2 minus f of 1 over 2 minus 1. Okay, so let's plug in 2 in this function. When you plug in 2, you're going to get 8 minus 6 plus 1, which is 3. Okay, minus, then when you plug in 1, you're going to get 1 minus 3 plus 1, which is negative 1. All that over 2 minus 1, which is 1. And that's going to give me 4. Well, 4 is not close to 0. But if you want to get an approximation that is close to the actual slope, then what point you might want to pick for the x will be a better choice. 1.0001. And if you want to get even closer approximation, you would pick even closer to 1. Or you can even pick 0.9999999, okay? But that's the whole idea, okay? That you want to pick something close to 1 to get an approximation. Okay, so let's go to now, how about 41 through 47 odd? So on page 198, 41 through 47 odd. Okay. 45 what? D is in cat, okay. Okay. Alright, is that it? Nothing else? 1 through 47 odd? Okay, 45D. Okay, 45D, you have y is equal to 5x squared minus 3, okay, times 7x to the third plus x. And they want me to find d squared y over dx squared. This really means they want me to find the second derivative, or f double prime of x. Alright, now, if I take the derivative of this as is, I use a product rule, it's going to make my derivative long. And I have to take a second derivative, it's going to make it even longer. So sometimes it's easier to just do algebra first and then take a derivative. In this situation, when you're taking a second or third, fourth derivative, okay, you're better off doing some algebra first. So I'm going to multiply these together. So my y prime turns into 35x to the fifth plus 5x to the third, and then minus 3 times that is negative 21x to the third plus or minus 3x. So if I clean that up, oh, that's my y, it's not y prime, sorry, it's still my y. That's my y. So my y is equal to, okay, 35x to the fifth, and when I put them together I get negative 16x to the third minus 3x. Now I can take a derivative of this. Okay, so 5 times 35, what is 5 times 35? What is it? 175, x to the what power? 4. And 3 times 6 is 48, right? X to the second, minus 3. Okay, my second derivative would be 4 times 175, which is 700. X to the third, minus, and this is going to give me 96x. And that's it. That's easier to do than taking a derivative as is and using a product rule. Okay, alright. Questions 73, 75, 77. 73, 75, 77. What do you want to see? 77? Lily, you got any questions? I'm not staying after school to answer your questions. Ask now. 75. 75. And I'm not answering questions on Facebook tonight either, Lily. X squared plus x plus 1. X is less than or equal to 1. 3x. Okay, pay attention. This shows up on AP test. And they are very stickler for this, the way you do this. So therefore, I am going to start slashing and burning if you don't do it right when it comes to grading. And we'll have the pleasure of doing that. Yes. Okay. Now they give you piecewise functions, and this will be a free response question. Okay. You'll have to find out if this is differentiable at 1. So they're asking you, can you find f prime of 1? That's their question. Is there derivative? Can you find that if it is? So to do that, okay, you have to satisfy one condition first. You have to prove that f of 1 f of x is continuous at x is equal to 1. That means they have to be connected. If they're not connected there, and if they're not defined there, then you got a problem. So if you have at 1, if the curve does that, you can't take a derivative. If a curve does this, if you have a corner, you cannot take a derivative of that. Or if you have a vertical asymptote, okay, at 1, okay, you cannot take a derivative. Okay, so first you got to check for continuity. How do you do that? You got to take a limit from both sides first. You got to go limit as x goes to 1 from the left side. Which one do I use for that one? So x squared plus x plus 1. Notice what I'm doing. I'm writing everything down. If you don't do that, you're in trouble. It's going to be 1 plus 1 plus 1, which is equal to 3. Then I have to take a limit, okay, as x goes to 1 from the right side. I use 3x, which is going to give me 3. Okay, that means they both go to the same place, but it doesn't mean it's continuous. It means it's going to the same place. It could have a hole. So you got to find out what is f of 1. So which one do I use for that one? Top one. That's 1 plus 1 plus 1, which is equal to 3. Now, when that happens, you have a trifecta. Then you can say f of x is continuous at x is equal to 1. Okay, you got to establish that. If you don't establish that, you can't talk about the derivative anymore. Okay, that means we can go on. Now, if it fails right there, then the game's over. Then you say it's not differentiable at 1, and you cannot find a derivative. Okay, no solution. Okay, but we're okay in this situation. Then we take the derivative of this piecewise function. Okay, we take the derivative of the top, which is 2x plus 1 when x is less than or equal to 1. Notice I'm putting the restrictions. If you don't do that, you're in trouble. 3 when x is greater than 1. Okay, this is the derivative. Now you got to check and see if the derivative is the same from both sides. Okay, so I got to take a limit as x goes to 1 from the left side. Which one do I use for that one? Okay, so 2x plus 1, which is going to give me 3. Then I have to find the derivative. Okay, limit as x goes to 1 from the right side. Which one do I use on that one? 3, which is 3. So far, so good. Okay, then you have to find f prime of 1. So which one do I use for that one? Top one. So 2 times 1 plus 1, which is 3. So they all match up. So I can say, okay, f is differentiable, means I can take a derivative at x is equal to 1, okay, and f prime of 1 is equal to 3. And that is what you have to do for a free response question. Okay. So that's 75, so let's go to 77. 77. 77, you have f of x is equal to x squared when x is less than or equal to 1, and rad x when x is greater than 1. Alright, determine if f is differentiable at x is equal to 1. If so, find the value of the derivative. Okay, that means same thing. They want me to find out if I can take a derivative of this function at 1. But before I can talk about derivative, I have to talk about what? Continuous. So I got to find, is f of x, okay, is f of x continuous at x is equal to 1? Okay, that's what I'm checking. How do I check that? I take a limit. Okay, limit as x goes to 1 from the left side, which is x squared, which is 1, and then I take a limit as x goes to 1 from the right side, which is square root of x, which is equal to 1. Okay, then I got to find out what is f of 1 itself, which is 1 squared, which is 1. So far, they all three match up, so I can say that f of x is continuous at x is equal to 1. Now, I am going to take the derivative of this piecewise function, which is going to give me 2x on the top when x is less than or equal to 1, and which is going to give me 1/2 x to the negative 1/2 when x is greater than 1. Okay, then I got to go through the same process again. Limit as x goes to 1 from the left side, which is 2x. That's going to give me 2. Limit as x goes to 1 from the right side, which is 1 over 2 times square root of x, which is going to give me 1 over 2. So therefore, I can say f of x is not differentiable at x is equal to 1. Now, let me tell you what kind of a graph you would get if you were to graph this. Okay, the value exists, okay, except the problem is that it goes to has two different slopes. So that means what you have is you have a parabola, which is this right there, okay, like that, and then this is a square root function, which is like that, okay. So what do you have? You're going to have a corner right there. Okay, that's why the derivative doesn't exist. Okay, all right. So we're done with that section. So let's go to questions taking a derivative the long way. (9 through 25). 15, 25, 13. You don't have a question on 23? We're good? Okay. 23? Okay. You have a book in front of you? Better have a book in front of you. Okay. All right. So let's start with 13. Okay, 13. Got f of x is equal to square root of x plus 1. Okay, and they want you to find f prime, or they want you to find the equation of a tangent line at x is equal to, okay, at x is equal to 3. Okay, at x is equal to 3. What two things do you need to find the equation of a line? Point and slope. There you go. I have 3. How do I find the y value? Plug in 3. You're going to get rad 4, which is 2. That's done. Now, this is 8? Okay. Alright. X is equal to 8. 8, so that's going to give me 3. Okay. Alright, now I have to take the derivative the long way. Okay, I'm going to tell you again, I will take points off if you don't write this. Tell it to you right now. You must write f prime of x is equal to limit as h goes to 0 f of x plus h. Now you can use delta x minus f of x, all that over h. If you do not write that, if you do not write this in front of it, you're losing points. Yeah, I can 1 point you all the way down. Okay, this is limit as h goes to 0. This means go to the function, plug in what for x? X plus h, so be that. And then minus f of x, which is rad x plus 1, all that over h. Okay, if you were to plug in 0 now, you're going to get 0 over 0. That doesn't work, so you have to do you multiply by the conjugate, which is our trick. So square root of x plus h plus 1 plus square root of x plus 1. Multiply top and bottom by the conjugate of the numerator, so it'll be x plus h plus 1 plus square root of x plus 1. Right. This now becomes limit as h goes to 0. These two are difference of two squares, so that means radicals are going to disappear. I'm going to get x plus h plus 1 minus x plus 1. Notice I put parentheses around that. Otherwise you're going to end up messing up. Okay, that's h times quantity square root of a x plus h plus 1 plus square root of x plus 1. Okay, now we're going to do some algebra. Okay, now x and negative x cancel, 1 and negative 1 cancel, the h is now finally reduced. Okay, you have a limit as h goes to 0, 1 over square root of a x plus h plus 1, okay, plus square root of x plus 1. Okay, so I have not done any calculus yet in this problem. Now I'm going to do calculus, which is taking a limit. How do I do that? Plug in 0. So I get square root of x plus 1, okay, plus square root of x plus 1. How many x plus 1s do I have? Square root 2 of those. 1 over 2 rad x plus 1. That is the slope. This is the point. How do I find the slope of this curve at this point? Plug it in. Okay, so f prime of 8 is going to be 1 over 2 times square root of 9, which is 1 over 6. So equation of a line is y minus 3 is equal to 1/6 times x minus 8. And those of you that are in love with y is equal to mx plus b, still working. Okay, yeah, get away from that. Y is equal to mx plus b. Alright. So that is 13. So let's go to 15. Okay, 15. At y is equal to 1 over x. They just want me to find the derivative of this. That's all. Okay? So do it the long way. Okay, f prime of x is equal to limit as h goes. I'll use delta x this time. Okay, limit as delta x goes to 0. Okay, of f of x plus delta x minus f of x. All that over delta x. That is the definition of a derivative. Now we're going to apply that definition into this specific function. When I do that, I get 1 over x plus delta x minus 1 over x on the top. All that over delta x. Of course, I got to add, subtract two fractions, so ancient and secret comes in real handy here. Multiply, multiply, and multiply. Okay, when you do that, you get limit as delta x goes to 0, x minus delta x, all that over x times quantity x plus delta x. Now, where will this delta x end up in this fraction when you were to simplify that? Top or the bottom? Bottom. So let's put that right there. We have that. The x's now cancel off. The delta x's reduce. I get a negative 1 on the top. Okay, so I have a limit as delta x goes to 0, negative 1 over x times x plus delta x. Now we do calculus. Okay, what do I do? Plug it in. How hard is calculus? X times x, which is negative 1 over x squared. That. Okay, 17. 17, you have y is equal to ax squared plus b. Okay, they want you to find y prime of x. Well, we know what y prime is going to be is 2ax, right? Well, we can't do it that way. So we got to go the long way. F prime of x is equal to limit as h goes to 0, f of x plus h minus f of x, all that over h. There is a reason I'm writing this down every single time. It is not because I don't know the formula, it is because I expect you to do the same thing. Plug it in, you're going to get a times x plus h, quantity squared plus b, and then minus f of x, which is ax squared plus b. If you forget the parentheses on the second half, you're going to end up making a mistake because it won't distribute the negative sign. Okay, we're all experts in algebra, so we can expand this binomial rather quickly. X squared plus 2xh plus h squared. Okay, and then you have plus b, and then minus ax squared minus b. All that's going to be over h. Now let's clean this up real fast. This is negative ax squared, this is positive ax squared. Okay, this is negative b and positive b. So everything else on the top, now I have a limit as h goes to 0, a times that, which is going to give me 2axh, and a times this is going to give me ah squared, all that over h. What can I factor out? H and reduce, so that gives me, okay, h goes to 0, limit h goes, notice I keep writing limit because I haven't taken the limit yet, so 2ax plus ah. How do I take a limit? Plug it in. When I plug it in, I get 2ax, and there it is. Okay, the long way. Alright, you like the short way. Yeah, I bet you did. Okay, number 19. Y is equal to 1 over square root of x. Okay, we're finding y prime. Okay, y prime is equal to limit as h goes to 0. I have 1 over, oops, I better not do that because then you will do it and then I get mad. X plus h minus f of x, all that over h. Okay, this is limit as h goes to 0. Okay, 1 over square root of x plus h. Okay, minus 1 over square root of x, all that over h. Okay, I can use the ancient Indian secret on this one because it comes in handy. Multiply, multiply, and multiply. When I do that, I get limit as h goes to 0, rad x minus rad x plus h. And when I multiply the bottoms together, I get rad x times rad x plus h. And where does this h end up in this fraction? In the bottom. Okay, so I'm in trouble because when I plug in 0, I have problems. So what do you think I might want to do right now? What's the thing we do all the time? Multiply by the conjugate. Here we go. So let's multiply by the conjugate. Limit as h goes to 0. Okay, when I multiply the top by the conjugate, that becomes difference of two squares. I'm going to get x minus quantity x plus h. And when I multiply the bottom by the conjugate, I have h times rad x times rad x plus h times the conjugate of the numerator is rad x plus h, and extend that line. Okay, x minus x is going to cancel out. Okay, and then the h's will reduce. I get negative 1 left on the top. Now I can plug in my 0. Okay, when I plug in a 0, I get a negative 1 on the top. On the bottom, I got rad x times another rad x, which is x, and then I have a rad x plus rad x because I'm plugging in 0 for h, okay, which is going to give me 2 rad x, and that is negative 1 over 2x times rad x, and there it is. Okay, 23. Alright, so 23. 23, we got to match up. You have a curve that looks like this. What's the slope here? Positive. What's the slope here? Nope, 0. It's flat. But what's the slope there? Undefined. So you got to find where the derivative is below the x-axis here, above the x-axis there, and it's not connected there, and it's on 0 there. Which one matches up with that? D. Okay, so we go to B. You have a graph that looks like this. Every place you see, the slope is undefined. Okay, this is going to be negative, then it's positive, negative, and positive. Okay, that means the slope curve is going to be above x-axis, below x-axis, above x-axis, below x-axis, and it's going to be broken all over the place. So which one is that? That is correct. Okay, C. You have a curve that looks like this. Oops. You have a curve that looks like that. Okay, what's the slope there? Nope, 0. So that means you better cross the x-axis right there at the origin. Okay, I have two options. I have either B or E. Okay, now slope is getting 0 here. Slope is flattening out there. So that means the derivative has to be close to 0 on the left and the right, which is B. Okay, so the next one, D. The D looks like this. You have a horizontal asymptote and you have vertical asymptote. Okay. Oh, they're connected. Are they connected? At 0. Okay. So, now, what's happening is it's flattening out. The slope is getting close to 0 to the left and the right. Which one has slope that's getting 0 left and the right? Okay, that is C. That's what's left, right? Okay, C. And then E. E, my curve looks like this. It's flat. That means slope is close to 0 and gets really big, and then slope is flat again, so slope is close to 0. So which one is that? Okay, A. Okay. So, and then the last one is what? E. Okay. All right. So one last. So I'm out of time. So sit down. I got 1 minute left. So what's left in this section is